Hi, in this video we will be discussing about implementing insert beginning operation in array implementation of list. In the previous video we were discussing about how to create an empty list and how to destroy a list, and then how to check if the list is full and if the list is empty. Those operations already we have done and the code is ready. Now we are going to add one more operation into the array implementation, that is insert at the beginning. So we will write the algorithm and then we will do the implementation for the developed algorithm. Step 1 says that if the list is full, then return false. In all the insertion operation, this will be the first step. If the list is full, then we are not going to insert, and the return type we are going to communicate through the return value. We are going to communicate whether the insertion was successful or not, because there is a chance of failure. We use the return value for communicating that. In the case of the list full, it is a failure, so we have to return false. And if the list is empty, this is a special case that is taken in the perspective of algorithm. We will see whether we have to take this as a case while implementing. Okay, so if the list is empty, then place the element as the first and increment the number of elements in the list. Okay, two things you have to do. First thing is you have to place the element as the first element, and also you have to increment the number of elements in the list, and then you have to return true. And step 3 is create an this is actually these are functions, so I am not putting the else and so on, since I have included the return in the step itself. As a part of the step itself, I have included return. So if the next step is going to be read, then it means that none of the above two cases will satisfy. So this is the case when you have got few elements in the list and you are going to do a insert beginning. So in that case, the algorithm states that create an empty space in the beginning of the list by shifting all elements by right one place and place the new element in the beginning, increment the number of elements in the list. Okay. So to understand that, let us assume that you have got a hall. In that hall there are totally 5 chairs. So how many people can be made to sit is only 5. Assume that there are already 3 people, okay, and the 4th person is coming, and you want to place the 4th person, you want the 4th person to sit in the first chair, okay, and assume that only one person can stand at a time, right, like that, only one person can move at a time. Then what we will be doing, we will ask the 3rd person to occupy the 4th seat, and then the 2nd person will be occupying the 3rd seat, and the 1st person will be occupying the 2nd seat, so that the 1st seat is free. Now the new person will be seated in the 1st seat, right? Like this we can do, right? This is just a analogy I am trying to bring in when you have to do a insert beginning in the array implementation, right? Like this we are going to do. That's how we are going to do. So when you look at it, actually what happens is, when a new person comes, he has to wait till all the people move right by one place, and then only he can sit, okay. And I have told the constraint also that only one person can move at a time, okay. So the time taken, for example, if I say that 1 second will be taken for one person to move right, okay, then totally if there are 3 people, there will be 3 seconds taken, 3 seconds will be taken totally, and if there are 5 people, 5 seconds will be taken. If there are 10 people already seated, I am talking about a bigger room, okay. If there are 10 people, then it will take 10 seconds and so on, okay. And you see that the time taken is based on the number of people already seated on the chairs, okay. So we will tell the time complexity. It is very important that you have to know the time complexity of each and every operation. Whenever it depends on the number of elements, then it will be coming in the means of n. Here n indicates the number of elements. As the number of elements increase, it is directly proportional. You can see that if there are 5 people, it is going to take 5 seconds, 10 people 10 seconds, if there are 100 people, it is going to take 100 seconds, right. So we will be using something called as big O notation. You may know in detail when you are going to learn the algorithm subject. just I will give you an overall idea about this big O notation. In big O notation, it is like a abstract way of telling, measuring the time. It's not the exact way. What I tell is, it is not like it will take 5 seconds, 10 seconds an operation. For each and every operation, you can measure the time complexity, and it will be told in big O notation. There are many other notations like theta notation and so on, but generally big O notation is used. In big O notation, the original time taken will be less than or equal to big O of whatever you are telling, either n or n square and so on, right? And one thing that we have to remember is, when there is a linear relationship between the number of elements and the time taken for the operation, then we will be telling us big O of n, right? Okay, this much is enough regarding big O notation. Now let us go into the implementation. So already I have got these functions implemented. In the previous video I have explained it. We have written create list function, print list function, destroy list, is empty, is full. Already these are ready. Now we are going to add one more function, that is insert beginning, right? Insert beginning is the function that we are going to implement now. Look at the return type of the function. I have given as int because I am going to tell true or false. But in C there is a restriction. I do not have a boolean data type. So I am going to return 0 on to indicate that it is a failure, and 1 for indicating that it is, the operation is successful. Okay, and I have to pass the list. Let us just think a while. Actually the algorithm states that you have to make changes in the number of elements. Okay, so when you look at this number of elements, this is part of the list, and I have to make changes in the function, and that should get reflected everywhere, right? And already the return type I have reserved for communicating the success or failure of the operation. I cannot return the list now. In create list we were returning the list so that the changes whatever we have made will get reflected in the place of call of the function. But here it is not possible, so I am going to pass it by address. That is what I am going to do. And the next argument is the element which is going to be inserted. Okay. So in C implementation we have to pass the list also explicitly, and now we are checking whether the list is full. So how you can check is full, right? You call the isFull function and you have to pass the list, but here address of the list is only present, right? Actually in L address of the list is present, but isFull operation, when you see, it takes the list. So just put a dereferencing operator in front of it and then you tell, and now you can return 0. Okay, if the list is full you are going to return 0, otherwise you are going to proceed. What will we do? We have to just move the elements as I was showing here. I have to start from the last person. I have to start from the last person and I have to shift by 1. And in C language you have to make the declarations in the beginning itself. So I have declared a int here, and then I am going to write a for loop for I equal to number of elements. Okay, number of, okay, it's inside L, so I should say L number of elements, right? L number of elements minus 1. Why? Because indices starts from 0 and I am going to tell I greater than equal to 0, I minus minus. Okay, because I am coming from the last, and after each iteration I will be moving towards the left. So I am telling I minus minus. What I am going to do? I am going to move the elements, right? Move the elements at the location I to I plus 1. Okay, so you tell L elements I plus 1 is equal to L elements of I. That is what we are basically doing, isn't it? So what I am doing? I am going to move from the 3rd position to the 4th position, right? So I plus 1 will be equal to I. So all the elements will be copied and my first position will be free at this point. So I will be telling elements of 0 is equal to x. This is what I will tell, and I will tell return 1 because this is a successful thing. if the space is available, right. So I am just returning 1. Let us come to the main and write. Okay. First of all, we are creating. I am removing the unnecessary prints so that you don't get confused. After creating the list, let us just check whether the list is empty and then is full, right. And one thing that we have to do is in print list, let us write up to number of elements. That's enough. Okay, we need not print all, because we did this in the previous session, because actually number of elements was 0 without insertion. So to print and see what is initially in the list, we did that. Now I have made it to print only values less than or equal to number of elements, right. And then what I am doing, I am going to just add elements, right. So call the insert beginning function, and you have to pass the list by address. So ampersand L, and let me insert 3. I am just going to tell the values, and then you tell insert beginning, and then you tell 2. Okay, and let us tell insert beginning ampersand L, let us tell 1. Okay, so first you are inserting 3 and then 2, 1. Since you are inserting at the beginning, 3 will go to the last, because when you insert the other 2 elements, it will be shifting as we have seen. Now you can call the print list function and see whether things are done properly, and after this once again we can check. Right, I am going to give the capacity to be 3 and check, right. So now if I try to insert, actually it should tell insertion failure, right. So I am just going to put a not operator and call this function. Okay, so not of insert beginning, I can even put the not inside, I think that will be better. Okay, so you are calling the insert beginning for the 4th element, and if it is false, right, that is what we put not, we are going to tell that insert has failed, right, insertion failed. We will give this message and we will just put semicolon, right. Yeah, let us try to compile the code and see. It's compiling, let us give and give 3. Okay, yes, why it's not printing? It's not printing because I have missed incrementing the number of elements in the insertion, right. This is a flaw, so it was not printing. Let us try again. Yeah, so you can see here I am giving the capacity to be 3. I can insert only 3 elements, that is what I mean, and this one is due to the checking of is empty. Initially the list is empty and is full is 0, right, and I am inserting 3. If I print and see, you can print and see, I will share the code in the GitHub, you can print and see after each insertion also, you will have a better idea. Only 3 will be there and then 2 will go on, and after that 1, right. During each insertion, as we discussed, the person is going to move or the element is going to move, right. And when I try to insert the 4th element, since I have given the capacity as 3, right, I will get a insertion failure, right. Okay, you can check the code. I will provide the link in the description box of my GitHub account. You can check and work on it. Thank you.